Hello students, welcome you all to the session for GATE 2023 Strength of Material Subjects Civil Engineering forenoon paper. So moving on to the first question. A hanger is made of two bars of different sizes. Each bar has a square of cross section. The hanger is loaded with 3-point loads in the mid vertical plane as shown in the figure. Ignore the self weight of the hanger. What is the maximum tensile stress in Newton per meter square anywhere in the hanger without considering the stress concentration effects? So one diameter is of 100 mm and other one is of 50 mm. 100 kilonewton load is acting downward and a 50 kilonewton is acting on the 50 mm diameter block. So when we are talking, first I want to go with an FBD diagram. And this is a basic question from simple stresses and strains. When I talk about an FBD, 50 kilonewton will be acting downward here and 50 kilonewton will be acting upward here. When I talk about area, it will be 50 into 50. Next, here when we talk about the forces, 100 which is coming down and there is also a 50 kilonewton load, 100, 200 plus 50, it will be 250. This will be 250 and obviously opposite side also you'll have 250 kilonewton. Area will be 100 into 100. So obviously what happens when I talk about stress, this is AB, this is BC. Now sigma AB is equal to PAB by force by area. 250 into 10 cube by 100 into 100. You'll get around 25 Newton per meter square, mm square. For suppose you are going with BC, stress is force per area 50 into 10 cube by 50 into 50. You'll get 20 Newton per mm square. So he is asking you anywhere in the hanger without considering the stress concentration. So obviously sigma max where you are going to get at AB 25 Newton per mm square. Option B will be the appropriate right answer for the given question. Moving to the next question. Consider the beam shown in the figure not to scale on a hinge support at end A and the roller support at end B. The beam has constant flexural rigidity and is subjected to external moment of magnitude m at 1/3 spans as shown in the figure. Which of the following statement is true? A. Support reactions are 0. B. Shear force is 0 everywhere. C. Bending moment is 0 everywhere. D. Deflection is 0 everywhere. So when we are talking regarding the free body diagram of this beam again, this is from beams, right? Shear force, bending moment. We have a fixed end A, B. You'll have a moment acting on it. Obviously length is L, L and L. So basically when we talk here, you have some reactions RA and RB. When we are using equilibrium condition, moment about A equal to 0, minus M plus M minus RB into length is 3L is equal to 0, RB equal to 0. Now all the vertical forces should be equal to 0, RA plus RB should be equal to 0, RA equal to 0. What happens? There is no shear force only, right? You'll have a straight line shear force and due to bending you'll be having like when I talk about SFD A, B, the total length is 3L. When I talk about BMD A, B, C, D. right? Negative bending you will get at a length of L, L and L. Okay, so obviously the curvature is at CD and deflection is 0 everywhere. So what will be the answer? Shear force will be 0. Option B will be the right answer for the given question here. Moving to the next question. The infinitesimal element shown in the figure represents the state of stress at a point in a body. What is the magnitude of maximum principal stress in Newton per mm square is an integer at a point. A body is given to you where 6 Newton per meter square is acting in the y direction. Alright, and let this be the x plane. This is making an angle of 45 degrees. This is x dash x. There is a normal force here also, it is 45 degrees, right? So basically, when we talk about this sigma x, sigma y, 45 degrees, right? You'll have tau xy 3 Newton per mm square. This is tau xy. This is tau xy, right? Where sigma y will be 6 Newton per mm square. Now, when you are solving on this, when you have x dash plane, you have 5 Newton per mm square, right? And tau xy will be 4 Newton per mm square. Obviously, the plane which is perpendicular to this. So when we are using the transformation equation, we get sigma x dash is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy sin 2 theta. So 5 is equal to sigma x plus 6 by 2 plus sigma x minus 6 by 2 cos of 2 into 45 degrees plus 3 sine 2 into 45 degrees. You will get the value of sigma x minus 2 Newton per mm square. So when you are talking about major axis, sigma x plus sigma y by 2 plus or minus root sigma x minus sigma y by 2 whole square plus tau xy whole square. That will be minus 2 plus 6 by 2 plus or minus root minus 2 minus 6 by 2 whole square plus 3 square, which will be 2 plus or minus 5, which will give rise to 7 Newton per mm square or minus 3 Newton per mm square, or megapascal also you can write, right? So obviously answer will be maximum of 7 Newton per mm square, right? By this, we have completed the questions of GATE 2023 Civil Engineering Strength of Material subject of forenoon. Hope you people have understood, students. Thank you. Welcome you all to the session for solutions of GATE 2023 Civil Engineering branch Strength of Material subject set 2, that is afternoon paper. A circular solid shaft of length 5 meter fixed at one end and free at other end, a torque T equal to 100 kilonewton meter is applied at the free end. The shear modulus and polar moment of inertia at the section are G and J. The torsional rigidity is 50 kilonewton meter square per radian. The following are reported for the shaft. Statement 1. The rotation at the free end is 0.01 radian. Statement 2. The torsional strain energy is 1 kilonewton meter. With reference to above statements, which of the following is true? Both the statements are correct. Statement 1 is correct and statement 2 is wrong. Statement 1 is wrong and statement 2 is correct. Both the statements are wrong. When you see the solution for this, there is a shaft which is revolving with torque of 100 kilonewton meter. You have Gj equal to 50,000 kilonewton meter square per radian. Length of 5 meters you are going to have. 5 when you are talking A and B. Phi of BA will be TL by Gj. 100 into 5 by 50,000, which will be 0.01 radiant. Torsional strain energy U is equal to T square L by 2Gj, right? Or half T into phi of BA. Substitute in this 1 by 2, 100 into 0.01. You will get it as 0.5 kilonewton meter. You will get it as 0.5 kilonewton meter. So obviously, statement 1, the rotation at free end will be some value of 0.01 and statement 2 will be wrong. Option B will be the right answer for the given question. When a simply supported elastic beam of span L and flexural rigidity EI is the modulus of elasticity, I is the moment of inertia of the section and is loaded with a uniform distributed load W per unit length, the deflection at the bit span delta is 5 by 384 WL per 4 by EI. If the load on one half of the span is now removed, the mid-span deflection is reduces by delta naught by 2, reduces by the value less than delta naught by 2, reduce the value greater than delta naught by 2 remains unchanged. So obviously when he is saying that a simply supported beam with an uniformly distributed load L by 2, you will have a deflection in this way, right? Where delta is 5 by 384 WL power 4 by EI. So when we talk about the condition, uniformly distributed load is this. So you'll have a span of L by 2. This you call it as delta Cj. The same happens onto the other one. So mirror case, that is nothing but if I want to write in this way. Alright. So case 1 and 2 are the mirror images and we can clearly say that delta C at 1 and delta C at 2 are same. So obviously what happens, the value will be delta C by 2, right? So obviously it is reduced by delta C by 2. Question from your normal beams, right? Flexural rigidity of beams. Option A will be the right answer for this given question. In a two-dimensional stress analysis, the state of stress at point as shown in the figure, value of length PQ, QR and RP are 4, 3 and 5. The principal stresses are dash, round off to 1 decimal place, sigma x is 26.7 megapascal, alpha y is 172.5, sigma x is 54 megapascal, sigma y is 128.5 megapascal, sigma x 67.5, sigma y 213.3, sigma x is 16 megapascal, sigma y is 138.5 megapascal. Now when we are seeing this diagram here, the conditions are like angle theta or this is theta, x dash, sigma y, sigma y, right? Tan theta is equal to QR by PQ, which will be 3 by 4, right? Theta equal to tan inverse 3 by 4. That will be 36.87 degrees. When we are using some transformation equations like sigma x dash equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. 120 is equal to sigma x plus sigma y by 2 sigma x minus sigma y by 2 cos 2 into 36.87 degrees. Tau x dash y dash will be minus of sine 2 into 36.87. So obviously when you are solving these equations, right, both equations you should get sigma x value and sigma y value. Solve it, you should get around 67.5 megapascal and 213.3 megapascal. But this will be the answer here. So option C will be the right answer for the given question. Option C will be the right answer. A 2D thin plate with modulus of elasticity equal to 1 Newton per meter square, Poisson's ratio mu as 0.5. The displacement field in the plate is given by mu equal to cx square y and v equal to 0, and where u and v are displacements in meters, x and y directions respectively. C is the constant. The distance x and y along capital X and y respectively in meters. Stress in x direction is 40 xy Newton per meter square. Shear stress is ax square Newton per meter square. Now we write epsilon x equal to sigma x by E minus mu into sigma y by E. Epsilon y is equal to sigma y by E minus mu into sigma x by E. Tau xy is gamma xy by g1, where g will be equal to E by 2 into 1 plus mu, right? Where epsilon x plus mu into epsilon y is equal to sigma x by E minus mu xy by E plus mu sigma y by E minus mu square sigma x by E. From here we'll write sigma x is equal to E by 1 minus mu square into epsilon x plus mu into epsilon y, right? So sigma x equal to E by 1 minus mu square into dou u by dou x plus mu into dou u by dou y. That is sigma x equal to E by 1 minus mu square dou u by dou x. Will get how much? 2 xy plus 0. This is the condition, 2xy minus 0, right? Next, sigma x is equal to 2ECXY by 1 minus mu square, because C is there as a constant given to you in the question. Sigma x equal to 40xy, which is given. Now 2EC by 1 minus mu square is equal to 40, because sigma x I will be substituting 2ECXY by 1 minus mu square, right? So when you cancel, gamma xy equal to tau x by g, whereas g into gamma xy equal to tau xy. Substitute here, E by 2 into 1 plus mu dou u by dou y plus dou v by dou x is equal to tau xy. E by 2 into 1 plus mu into cx square plus 0 is equal to alpha x square. Alpha is equal to CE by 2 into 1 plus mu, where alpha is equal to 40 into 1 minus mu square by 2e into E by 2 into 1 plus mu. From here alpha is equal to 5 you are going to get. Substituting the values given here, you will be getting alpha is equal to 5. By this, we have completed the questions of GATE 2023 Civil Engineering